Imagine stepping onto a world where the sky blazes with not one but 7 suns, some so distant they barely warm your face, others locked in a fiery dance that turns day into an eternal twilight of overlapping shadows. Or picture a planet so hellishly hot that iron rains from its clouds like molten bullets, only to evaporate again on the blistering day side. What if there are worlds drifting alone through the galaxy's void, untethered to any star? Cloaked in perpetual darkness, yet possibly cradling hidden oceans beneath their icy crusts. Hey everyone, welcome back to Past Lives POV. I'm your name, and today we're diving deep into the most bizarre exoplanets humanity has uncovered so far. Our own solar system feels downright tame once you peer beyond it. Over 6,000 confirmed exoplanets and counting. Many defying everything we thought we knew about.
Welcome back. We're thrilled to have you join us.
This isn't just a list of weird worlds. It's a journey into the chaotic beauty of the cosmos that challenges our assumptions about life, stability, and what normal even means. Stick around to the end for the biggest takeaway that might just change how you see our place in the universe. Let's launch into it. First, let's talk time specifically. How long a year can last on these alien worlds? In our solar system, Mercury's 88 Earth day orbit feels quick, but it's nothing compared to the extremes beyond. Most exoplanets we detect have short years because of our methods. The transit technique, watching a star dim as a planet crosses in front, favors close-in worlds that repeat their dips frequently. That's why many known exoplanets whip around their stars in days or weeks, like those in the TRAPPIST-1 system. But the record holders are insane. There's a candidate orbiting a pulsar, a spinning neutron star, Remnant, with an orbit completing in under 49 minutes. Neutron stars are tiny and crushingly dense, bending light itself.
Contrast in orbital
This planet,
stability highlights the
stellar
Goldilocks
fragment,
position.
hugs it at breakneck
Earth's stable
speeds,
orbit allows
held
complex
by
life to
gravity that
thrive
can
in the
shred
habitable
anything too
zone.
fragile. For a main sequence star, K2137b takes the crown with a blistering 4.31 hour year. It's Earth-size, but skims so close it's likely inside the star's outer atmosphere, doomed to tidal disruption or a fiery plunge. On the flip side, some gas giants take up to 1 million years per orbit, leisurely cosmic wanderers, barely tugged by their distant suns. These extremes highlight a key insight I've pondered. Our calendar-based view of time is parochial. On a world with 1 million-year year, entire civilizations could rise and fall between seasons. It makes you appreciate Earth's Goldilocks stability, but also wonder if life could adapt to such rhythms elsewhere. Speaking of adaptation, let's get personal with multi-star systems. Growing up, I was obsessed with Star Wars Luke Skywalker watching Tatooine's twin suns set. Kepler 16b made that sci-fi real in 2011. A gas giant orbiting 2 stars, about a third Jupiter's mass. It's not a desert world, but the Tatooine planet proved circumbinary orbits are stable. Real-life parallel. Think of a sailor navigating by multiple lighthouses instead of one. In hierarchical multi-star systems, binaries orbiting binaries, up to rare setups with 6 to 7 stars planets can circle one star, a pair, a trio, or the whole chaotic family. A hypothetical planet in a 7-star system might see 7 faint suns from afar, 3 brighter ones closer in, or just one up close while tidally locked, its night side occasionally lit by distant planets. And astronomers estimate over half the stars in our galaxy have companions. Sirius, Alpha Centauri, Polaris, all multiple. Yet single stars like ours might be more common than we thought, especially among dim red dwarfs. Massive stars form in clusters and often pair up due to abundant material. Personal commentary and analysis. What if Earth had a close red dwarf companion? Our year shortens, seasons go haywire from the extra gravitational pull and flares. Summers could spike lethally hot when the dwarf aligns closest. Winters plunge cold. Auroras would dance nightly from stellar storms, frying satellites and power grids like a hemisphere-wide EMP. Blue supergiants.
By fire and starlight, we are bound to the celestial.
But wide binaries offer hope. A second sun visible at night like a bright star with minimal daytime impact. Still, If it's a supergiant, supernova risk looms. Radiation could sterilize planets even light years away. Now, a 2025 study reinforced that nearby supernovae pose existential threats. This isn't abstract. Imagine indigenous cultures on such a world developing myths around dancing suns or calendars tracking multi-body alignments. Life might evolve dual photosynthesis peaks or radiation-resistant traits. My insight: multi-star systems force us to rethink habitability zones. They're dynamic, not static circles. Contrast that warmth with rogue planets, free floaters unbound to any star. Billions to trillions may roam our galaxy, ejected during chaotic formation or failed star births. Detection story. Ground programs like OGLE and MOA use gravitational microlensing. Einstein's predicted bending of light. When a rogue passes,
The magnification peaked exactly as predicted.
VLT 2024 Alpha is confirmed. We should initiate the follow-up sequence.
A standout candidate, OGLE-2012-BLG-1323, might be Earth mass. NASA's Nancy Grace Roman Space Telescope, launched in approximately 2027, will supercharge this, potentially finding hundreds of Earth-like rogues by monitoring the galactic bulge. Relatable example. Picture a lone hiker lost in endless night, no camouflage map. Rogue planets are pitch black, but a thick hydrogen atmosphere could trap geothermal heat. Sustaining subsurface oceans like Europa, but without Jupiter's tides. Life there, chemosynthetic, vent-dwelling microbes akin to Earth's deep-sea ecosystems. No photosynthesis, but maybe bioluminescence or magnetic navigation. A 1999 paper suggested Earth-like conditions under ice. Recent models and JWST hints at rogue worlds with complex atmospheres. One analysis I love. These planets could be more common than we think, carrying life's building blocks across the galaxy like interstellar seeds. Ejection isn't always violent. Some form in isolation. Now, the infernos. WASP-76b, an ultra-hot Jupiter discovered in 2013, orbits in 1.8 days. Dayside, approximately 2,400 degrees Celsius, vaporizes iron. Winds carry it to the cooler night side, where it condenses and rains as molten droplets detected via spectroscopy by ESO's Very Large Telescope. Recent Cheops data even hints at a glory effect, rainbow-like concentric rings from spherical cloud droplets, a first beyond our solar system. Analysis: tidally locked, it has supersonic winds and extreme weather. It's a reminder that habitable zone is narrow. Push too close and chemistry goes wild. Hotter still, Kelt 9b, dayside approximately 4,300 degrees Celsius hotter than many red dwarfs. Its atmosphere boils off at 100,000 tons of hydrogen per second. Molecules shatter. It's a planet evaporating before our eyes. These worlds push planetary limits. That new 2025 to 2026 JWST finds include eccentric warm Jupiters and sulfur-rich magma ocean candidates, expanding our weirdness catalog. Size and rings. Size flips. Planets bigger than their stars? Tricky due to brown dwarf overlaps, but candidates orbit tiny white dwarfs or red dwarfs. WD-1856b survived its star's red giant phase, likely migrating inward. The visual champ J1407b's suspected rings span Venus orbit scale 40,000 times Saturn's area. A 95% starlight dip in 2012 screamed mega rings with moon-forming gaps. Confirmation wanes, no repeat eclipse, but if real, it's a Saturn on steroids. Imagine rings arcing across the sky like a permanent aurora highway. We've journeyed from iron rains and multi-sun skies to lonely rogues and ringed behemoths. These exoplanets aren't just curiosities. They reveal formation chaos, gravitational dances, and resilience. The universe thrives on diversity and extremes. Our normal solar system is one lottery winner among trillions of possibilities. This humbles us, sparks curiosity, and urges protection of Earth's fragile balance while we hunt for life's echoes elsewhere. What bizarre world fascinates you most? Comment below, like, subscribe, and join the Patreon for more deep dives. Thanks for watching. Keep looking up. End screen with calls to action.